Hey everyone, Bill Nye here. I hope you're ready for some truly mind-bending news from the far reaches of our universe. Right now, something extraordinary is unfolding, way out in the darkness of space, a place where mysteries are born and the unexpected is always just around the corner. Picture this, the universe, vast and unpredictable, has just thrown us a cosmic curveball. An interstellar visitor known as 3I Atlas has suddenly changed its path, catching astronomers everywhere by surprise. This isn't just another space rock drifting by, it's a messenger from the unknown, a traveler from another star system. And its sudden shift has scientists buzzing with excitement and curiosity. 3I Atlas was on a predictable course, following the laws of physics as we understand them. But then, out of nowhere, it nudged itself onto a brand new trajectory, defying our expectations. Our instruments picked up a clear, undeniable shift in its movement, something that simply couldn't be ignored. This is the kind of event that makes science so thrilling, and honestly, a little bit humbling. It reminds us that the universe is full of surprises, and we're just beginning to scratch the surface. The universe isn't always as neat and orderly as we'd like to think. Sometimes it throws us a puzzle that challenges everything we know. But don't panic, the world isn't ending. This isn't a disaster movie, instead it's a moment to pay attention, to be curious, and to marvel at what's happening above our heads. When an object from another star system behaves unpredictably, it's a wake-up call for scientists everywhere. Is it outgassing, releasing jets of material that push it off course? Is it being tugged by an unseen gravitational force? Or is there something even stranger at play? Right now, we don't know the answer, and that's where the real adventure begins. Every new observation brings us closer to understanding, but also opens up new questions. This is a real-life cosmic mystery, unfolding in real time, right above our heads. It's a story that's still being written. It's more than just a cool headline, it's a test of our ability to observe, to reason, and to work together as a global scientific community. What we learn from 3I Atlas could change our understanding of the universe and maybe even our place within it. It could help us prepare for future visitors, some of which might pose a real threat, while others could teach us more about the origins of our solar system. This is our chance to learn, to grow, and to appreciate the wild, unpredictable cosmos we call home. So, let's explore this together. Let's stay curious, stay inspired, and, who knows, maybe even change the world. For those who don't know me, I'm Bill Nye, the science guy. My mission: make science accessible, exciting, and fun for everyone. We're all born curious. Science is just a way of thinking, a tool for understanding our universe. Right now, that tool is more important than ever. Science solves big challenges and helps us answer the biggest questions. Where did we come from? Are we alone? When I talk about an interstellar object changing course, it's not just news, it's why science matters. Understanding how objects move through space helps us launch satellites, predict weather, and protect our planet. Every discovery, no matter how distant, adds to our knowledge and helps us thrive here on Earth. Science is a team sport, and we all have a role to play. The story of 3I Atlas is science in action, messy, surprising, and exciting. Join me on this journey. Let's be curious together. So, what is 3I Atlas? It's the third interstellar object we've ever confirmed. Most comets and asteroids are local, born in our solar system. But 3I Atlas is a tourist from another star. It was discovered by the Atlas telescope system in Hawaii, designed to spot moving objects near Earth. Astronomers quickly realized it wasn't moving like a local. Its speed and trajectory were all wrong. It's moving too fast to be captured by our sun's gravity, just passing through. Based on observations, 3I Atlas is comet-like, a mix of ice, rock, and frozen gases. As it nears the sun, it forms a glowing coma and tail, its chemical fingerprint. Studying that tail gives us a direct sample from another solar system. Before this, we'd only seen two others, Oumuamua and Borisov. Each visitor is unique, offering a new perspective on how planetary systems form and evolve. These fleeting guests are precious opportunities to study material from another star up close. Let's talk about a trajectory shift. Imagine rolling a bowling ball down a lane. Its path is set unless something nudges it. For celestial objects, gravity usually rules, letting us predict their paths with amazing accuracy. When we first spotted 3I Atlas, we calculated its path. Everything matched. But then, it started to drift away from predictions, a gentle, persistent nudge. Think of a canoe drifting sideways in a river because of a breeze. That's what happened. Some force other than gravity gave it a push. Our instruments detected this tiny deviation from billions of miles away. Scientists call this a non-gravitational perturbation. For comets, it's usually outgassing. Jets of gas and dust act like tiny thrusters. If these jets aren't symmetrical, they push the comet off course. That's likely what's happening with 3I Atlas. It's changing its mind because its own body is pushing it onto a new course. This makes it a dynamic, fascinating object to study. It's not just a rock, it's alive with activity. 3I Atlas got a little push and changed its path. Why does that matter? At first glance, it might seem like a minor detail, but in the vastness of space, even the smallest nudge can set off a chain reaction of events. In space, tiny changes can have huge consequences over time. A slight shift in direction today could mean a completely different destination years or even centuries from now. A small, unexpected push means our predictions about its future path are less certain. The models we rely on become less reliable, and the margin for error grows. For Earth, there's no immediate risk. Its new path isn't bringing it closer to us. But that doesn't mean we can relax or ignore these changes. But this is a crucial lesson for planetary defense. Every unexpected event teaches us how much we still have to learn about the cosmos and its unpredictable nature. We track near-Earth objects assuming gravity is the only force at play, but the universe is full of surprises, and other forces can alter an object's path. But what if an object outgasses and nudges itself onto a new course? Outgassing can act like a tiny rocket, pushing the comet in unexpected directions. This event forces us to keep watching, keep updating our models, and stay alert for any changes, no matter how small they seem. We can never assume an object is safe forever. The universe is dynamic, and so are the objects within it. The safety of our planet could depend on how well we learn this lesson. Vigilance and adaptability are key to protecting Earth from cosmic threats. For science, the outgassing gives us a golden opportunity. Each burst of gas is like a message from the distant past, waiting to be decoded. Those jets of gas are material from another star, preserved for billions of years. They carry secrets about the building blocks of other solar systems. By analyzing it, we learn about the chemistry of its home system. This helps us understand how planets and life might form elsewhere in the galaxy. The unpredictable nature of 3I Atlas makes it a scientific treasure. Every twist and turn adds to our knowledge, reminding us how much there is still to discover. Interstellar objects like 3I/Atlas are among the most thrilling and mysterious frontiers in modern astronomy. These rare visitors traveling vast distances between the stars offer us a unique opportunity to study material that was born far beyond our own solar system. For centuries, humanity's gaze was limited to the planets, comets, and asteroids orbiting our sun. But now, for the first time in history, we can observe and analyze messengers from other stars, cosmic travelers that carry secrets from distant worlds. By studying the gas and dust released by 3I/Atlas, astronomers search for chemical fingerprints, like the ratio of heavy water to regular water, or the presence of complex organic molecules. These details can reveal whether the building blocks of life are common throughout the galaxy, or if our solar system is truly unique. These chemical clues tell us about the environment where the object formed and hint at whether life's chemistry might take different paths in other corners of the Milky Way. These interstellar visitors also help us understand how planetary systems are born and change over time, how some objects are flung out by gravitational forces destined to wander the galaxy for millions or even billions of years. Each new discovery is a piece of a much larger puzzle, helping scientists refine their models of how our own solar system, and others, came to be. Oumuamua was a mystery Borisov felt more familiar, and 3I/Atlas highlights the surprising importance of non-gravitational forces, like jets of gas, in shaping the paths of these cosmic wanderers. Each interstellar visitor reminds us that the galaxy is far more diverse and dynamic than we ever imagined, filled with wonders waiting to be discovered. These objects are not just cold, lifeless rocks. They are precious clues, each one a chapter in the grand story of cosmic evolution, connecting us to the wider universe. Every molecule we find is like a word in a message sent across the stars, inviting us to read and understand the history of worlds beyond our own. My big worry isn't that 3I/Atlas is a threat. It's the uncertainty it represents. We've built amazing systems to track asteroids and comets, but we assume gravity is the only force at play. 3I Atlas proves that's not always true. Comets can change course, powered by their own internal activity. This adds complexity to planetary defense. We can't just find these objects and forget them, we need continuous observation. We must invest in characterizing these objects, what they are, not just where. More missions, better telescopes, and global cooperation are essential. Understanding non-gravitational forces is practical work for our survival. This is a global issue, no single country can do it alone. My worry is a call to action. Take cosmic impacts seriously and invest in science and technology. The universe is telling us, don't get too comfortable. So what can you do? Start by looking up, foster your sense of wonder. Become a citizen scientist, help astronomers sort data, find comets, or classify galaxies. You don't need a PhD, just curiosity and a computer. By participating, you help expand our knowledge and protect our planet. Support science and education in your community. Advocate for funding, encourage STEM programs, and speak up for science. The technology we develop for space often leads to innovations here on Earth. Listen to scientists and seek reliable information. Be skeptical of sensational headlines. Think critically. The universe is amazing enough. We don't need to make things up. Your curiosity and critical thinking are our greatest tools. As we track 3I Atlas, it's easy to feel small, but I want you to feel hope. Every cosmic curveball is a chance to learn and grow. The story of 3I Atlas is about discovery, not fear. We are a species that looks up, asks questions, and dares to find answers. The same spirit that tracks an interstellar comet can build a sustainable future on Earth. The trajectory shift reminds us to be vigilant, adaptable, and forward-thinking. We must actively participate in securing our future. I'm optimistic. Young people today will build on these lessons. You'll design telescopes, write code, maybe even travel to other worlds. The future is something you build. Never lose your sense of wonder. As 3I Atlas fades, let it inspire us to care for our planet and each other. The future is in the stars. Let's keep looking up and changing the world.